the 2x in front and the 2 in front and the 4 in front.
Okay. So on all of our warm-ups today, they had a greatest common factor, which could be factored out. Oh, I used too many times.
Too many.
All right. So any questions about 1, 2, or 3?
Yes.
Which one?
Well, how do you
funny.
get the coefficients on the sides?
Oh, well, yesterday when we started factoring, we said we always want to look for a common factor first. Is there a term that will divide into all the terms we have? Well, yes, 2. So that always comes out first. So when we factor out the 2, we were left with x squared minus 4, which is a difference of squares. So the 2 stays out in front, and then we factor the x squared minus 4 some more. X plus 2, x minus 2. Okay, and so we factored out that greatest common factor. The term that was the greatest common factor factors out. So now we write it as a product of 2x times 1 minus y squared. Well, 1 minus y squared is a difference of squares, so we continue to factor. Yes, Drew?
I'm pretty sure I just figured this out, but on number 3, you don't even have to have the 4x in like your little answer, do you?
We do need the 4.
No, I mean, but like the 4x, it's in the middle of the trinomial.
This?
Yeah, it just you just
Well,
take
if you
the x and
multiplied
the
it out.
4, and you take like the root of that.
You look
and
at
then
this and
square
you look
it.
at this, but you do always have to double check.
And
Remember
then
how I said double your
you
product
double
and see?
that, and it'll
Yes.
be- yep.
Yes.
So how do you do number 3? Like, how do you?
You factor out the greatest common factor of 4, and then you see this is a trinomial. So yesterday when we looked at trinomials, all we focused on was perfect square trinomials. If the first term is a perfect square and the last term is a perfect square, we try to write it as a binomial squared. So we take the square root, the sign of the middle. If I double the product, do I get the middle term? Yes. So I write it as that binomial squared.
Okay, thank you.
Yes, ma'am.
How do you get the x on the outside of 2?
Out here?
Yes.
Okay. The first step is always to factor out the greatest common factor. So if we look at these 2 terms, what do they have in common? A 2 and an x. So it has factored out first.
So it's not just a constant.
It's not just a constant. In this case, our greatest common factor is 2 times x. Okay, so then we wrote it as the factors of 2x times 1 minus y squared, but 1 minus y squared continues to factor. Okay, homework. Now, number 18 should really be this. And number 32 should really be this. There we go. Because I ask y'all to always take out the greatest factor first and then factor completely. So check those and see if you have questions. The order of multiplication does not matter. Multiplication is commutative. Yes, Connor?
What was that example one where, yesterday there was like, instead of just 2,
It factored again.
yeah, like,
What happened was when I factored one of them, what I was left was still another difference of squares. So it's similar to number 25 because this is a square. But do you see how this is not a square? If that were 16, then we could factor some more.
and then which one would we lose though, both?
You would have, okay, if this was 9 plus 16x squared times 9 minus 16x squared, our answer would be this one that doesn't factor anymore. Whoops.
Oh.
Times this, 3 minus 4x and 3 plus 4x.
Okay.
All of those together would make up your
Okay.
completely flat factored answer. Let me see. Do you have your copy? was this your problem? X squared plus 14x plus fill in the blank? Okay, so what we're doing is going, what did I double here to make the 14? And it had to be 7. So 7 squared goes here, which is where we get the 49.
Okay.
Okay? Anything else? Yes, ma'am.
On 7, no. Is it 17? Or is it 18 and 32? How did you get those different answers?
Okay, 18. Do you see that 18, just like our warm-up problems, has a greatest common factor that should be factored out first?
Yeah.
So once we factor that out, then we can factor the remaining. So that's why I have different answers on 18 and 32. Because on both of those, we should factor out the greatest common factor first. Okay? All right. Now, yes, Carter.
On 28, could it also be negative 30x because you don't know if it's going to be a negative or positive?
Ooh, yes. Good. Plus or minus 30x. Very good. All right. Anything else? Yes, ma'am.
Numbers. Wait.
Numbers.
Oh, I marked the wrong one wrong. Okay.
Okay. All right. I do really like today because I think about factoring as a puzzle. All right. Okay, at this point, I need you to pay attention, and we're going to just take do lots of examples today. I'm going to teach by example.
All right.
No real notes, just teaching by example. And hopefully we'll do enough examples to where it'll make total sense. What time did you have? All right, so today we're going to continue factoring quadratic trinomials. But it's not a perfect square. It's not a perfect square. So what are other options? And negative 4. Is negative 4 a perfect square? No, only positive 4 is. So we have to think of another method for factoring. And we're going to take these quadratics and we're going to factor them into a product of binomials. So when we think about distributing through here, or you could, when we multiply two binomials, some of us think of it as foiling. To get y squared, wouldn't we do y times y?
Yep.
Okay, so we already have a nice start.
Nice.
We know what the first term in each of the binomials has to be. And then we just have to play around. And let's think about what the process does here when we FOIL it. Do you see that when I do this times this plus this times this, that gives me the middle number?
Yeah.
So I'm thinking about something that I add to get the middle number. And to get this last term, when I'm distributing here, it's this times this that I would multiply to get that last number. So when we are factoring a quadratic trinomial with a leading coefficient of 1, all you have to ask yourself is what two integers can I multiply to get the last term that I can add to get the middle term? What can I multiply to get negative 4 that I can add to get positive 3? So really we're looking at the factor pairs for 4, which are 4 and 1, and 2 and 2. Is there any way that I can multiply to get a negative 4 that I can add to get a positive 3? Who sees it?
4 negative.
4 and negative 1. Thomas, does that make sense? Okay, and so we're going to continue to ask ourselves those questions. Because of the process, you're asking yourself, what can I multiply to get negative 24? So let's think about my factor pairs for 24. 1 and 4, 2 and 12, 3 and 8, 6 and 4. Actually, 4 and 6, and then 6 and 4, so it starts repeating. Okay, so I want to multiply to get to a negative, and then add to also get a negative. What would it be? Negative 6 and positive 4. Multiply to give me negative 24, and add to give me negative 2.
Wow.
Could it be positive 6 and negative 4?
That would multiply to give me negative 24, but would it add to give me negative 2? No, it would not.
Oh, you add those two numbers together.
Right, because let's think about what we did before. We did first term times first term. Outside, inside gives us this, and we add those two, don't we? And then last gives us that. Okay, now let's think about 12. What are our factor pairs for 12? 1 and 12, 2 and 6, 3 and 4. Okay, I'm multiplying to get a positive. So my choices are they're either both positive numbers or both negative numbers, aren't they? So I'm multiplying to get a positive 12, and I'm adding to get a negative 7. What is it? Negative 3 and negative 4.
Can you do this on the ones that we did yesterday too?
Okay, now, some of you may look at this one and go, ooh, Miss Willoughby snuck in one from yesterday. Perfect square, perfect square. So let's try to write it like this.
That works.
Square root, square root. If I double the product, do I get the middle term?
No.
No. So this one does not work that way. Even though it looks suspiciously like a perfect square trinomial, it is not. But what can I multiply to get 16, positive 16, that I can add to get positive 10? 8 and 2. Okay, how many people like Math Puzzle Day?
Juliana likes Math Puzzle Day.
Cool. All right. You try.
Does it matter which number comes first?
The product of the two doesn't matter because multiplication is commutative. Like 2 times 3 is the same as 3 times 2. So if I have x minus 2 times x plus 1, but you have x plus 1 times x minus 2, we're both right.
Okay.
Because the order of multiplication doesn't matter. Now, where we put the positive and negatives and how we group them, that doesn't matter. But
Okay.
Now I get why.
15 and 2. 15 and 2. Negative 15.
Can we ask him like an
That's the exact same. Oh, plus 30.
Negative 10, negative 10. Yeah.
The middle number.
You all know it too.
Oh,
you're trying.
it's negative 30.
Isn't it clever how I gave you the same first term and used the same number for the last one? But made 4 different problems out of it.
You're so smart.
Yeah.
Oh, give me the opposite. Okay.
Start on a 38 problem.
They're fast.
Oh.
They're fast.
30 and negative. No, 30 and 1.
All right, quick time out to advertise for the upcoming
30 and negative.
party at the pit. It's our homecoming dance, Friday, September 20th. And if you look at these pictures, it looks like it's going to be really cool.
Oh, it'll be cool.
It'll be cool. It'll be cool. So make sure, I think you purchase your tickets during lunch.
Me and Hannah are going to. Sorry, that's not much fair.
No.
Yeah,
Usually,
she's right.
people have the most fun if they go with friends and just have a good time.
That was my question. So for 5, I got x minus 3. X plus 10, and she got x plus 3 minus 10. Which is, I don't know which
One of you is right, one of you. It's just sign switch. The sign has to be with the same number.
But how do you know? Okay. Never mind.
Okay,
You're probably right.
go back and distribute it.
Wow, stop really. Why are you looking at me? You. Okay.
Right. 2 and 15 is not the right number.
It has to be minus.
1 through 24.
What are your factors?
A negative times negative. more than 30
It does?
Yeah.
Okay. I was like, oh, what?
Yes.
Number 6.
Oh wow, we were way off on that. So neither of us were right.
Okay. All right, and Drew just made a good point. Those of you that rocked your multiplication tables are going to love this. Because you look at 30 and you automatically think of everything that makes up 30. The factor pairs for 30 are like flashing red lights in your brain. And you don't have any issues with this.
I did it.
Okay, so you thought of all the factor pairs really quickly, and that helped you go, ooh, for this one, I need a negative 15 and a positive 2. But for this one, I need a negative 10 and a negative 3. Whereas for this one, I need a negative 30 and a negative 1. But this one, I need a positive 5 and a positive 6.
I get it.
Okay, you got it?
Sylvia, I understand.
Yes, ma'am.
For number 5, I can negative 2 and a positive 16. Is that okay?
Okay, if we did a negative 2 and a positive 15,
Oh, never mind.
okay, you got it. If we FOIL it back, we don't get the right sign in the middle. Okay. All right. So now that we are like a champ at this one,
Yeah, you make me laugh.
let's do this kind.
So are these the puzzles?
Like, yeah, I like to do him.
Wait, what are we doing now?
Okay, so what we're doing now, we're still positive. All we're doing is going from where that leading coefficient was 1 to where the leading coefficient is not 1. It's something else. Okay? So, I'm going to teach by example. Example 9. Drew, you got to pay attention, yeah. All right, so the problem that I'm trying to factor is 5x squared plus 11x plus 2. Now, when we do not have a leading coefficient of 1, we have to think about what's got to go in our first position. So, not only do we have to think about the factor pairs for our last term, which luckily for this one, there's one factor pair when I give you a prime number, right?
2 and 1.
2 and 1. And ooh, I gave you a prime number here, didn't I?
5.
5 and 1. So there's only one way to divide these up. 5x, 1x. That's the only way to get 5x squared, right? But now I have to play a little. Because there's only one factor pair for 2, and I'm multiplying to get a positive, and I'm adding to get a positive, so both of these have to be positive. But I have to think about, where do I need to place the 2 and the 1 so that when I do this outer plus the inner, I get 11. What needs to go here?
The 2.
The 2. Because that gives me 10 plus 1 is 11.
Listen, out times out and in times in equal.
Mm-hmm.
Wow.
It's not that hard. You just need to do a couple. That's why I have several. Okay. And do you see the next one? I'm just giving you prime numbers so far.
Oh, yes.
All right, so number 10, 3x squared minus 4x plus 1. So my first term is 3x squared. What's the only way to break that up?
3x and x.
3x and x. And then this one's even easier because 1 and 1. So on this one, all I have to think about are the signs. I'm multiplying to get a positive, but I'm adding to get a negative. Negative 1, negative 1. Do you see that gives me negative 3x plus negative 1x. Is that negative 4x? Yep, we did it. Touchdown. Okay, you try example 11. am multiplying to get a -2, which means they have to be opposite signs, right? And I'm adding to get a +1. So if I have a +3 and a -2, that adds to give me +1, and it multiplies to give me -2. How'd you do?
It's like not thinking.
It is.
I don't like it.
Oh,
I don't like it.
yes.
Could you also get 3x plus 1 times -2x plus 1?
Let's try it. 3x plus 1 times -2x. Is that what you said?
Yes, plus 1.
Plus 1. If I do first terms, do you see that gives me -6x squared? Is that what this is?
It is not.
Okay, so that is not an option. Okay, and that's a good way to check. Foil it back. Distribute back through and see if you get what you started with. That is a great check step. All right, so now let's do ones that are not prime. Okay, so my example 12. 2 is prime. My leading coefficient is prime. But the constant is not prime. It has a couple different factor pairs. So I'm going to always start with the one that is prime. What's the only way to break up 2x squared?
2 and 1.
2x and 1x. And then the math puzzle begins. All right, I'm multiplying to get a negative, so I know that one has to be positive and has to be negative. And my factor pairs for 15 are 1 and 15 and 3 and 5. So we just have to, those are the only two options I have. So if I do 1 and 15, I need to get a 7. That would give me 15 and 2, can't make 7 out of that. 30 and 1, can't make 7 out of that. So 1 and 15 doesn't work. So let's try 3 and 5. So if I do 5 here, that's 10, and 3 here, ooh, 10 minus 3 is 7. So I need to make it a -3 and a +10 to give me the +7.
Plus 5.
Oh yeah, that's right now.
But you're plussing
That'd
10.
be 8. Should that be 10?
Oh.
So you multiply by the 2.
Classes.
Oh,
What?
2.
At moments it is.
No, like compared to last year.
No, okay.
Yeah. So
Last year.
All right, any questions about, yes.
So which ones are you multiplying to see how to get the answer?
Okay. When we just multiplied these out, do you remember we did first terms times first terms, gave us this one. Then we did this times here, and this times here, add up to give me the middle term.
Okay.
So I just think about it in terms of FOIL, I think about it as outer plus the inner gives me the middle. Okay, now this one, 8x squared minus 10x plus 3.
4 times
Okay, 3 is prime. 8 is not. So this time I'm going to start with 3. What is the only way I can multiply and get 3? 3 and 1. And I'm multiplying to get a positive, but adding to get a negative. So what does that tell me about the 3 and the 1? They're both negative. Now I have to play with 8 to figure out how to break it up. I've got, my choices are 1 and 8 and 2 and 4. If I did 1x here, that would give me 1x and -24x. Does that give me 10? No. So if I did 8 here, that would give me -8 and -3. Does that give me 10? So is the 1 and 8 going to work? No. So let's try the 2 and the 4. If I did 4 here and 2 here, that would give me 6 and 4. Does that give 10? Yes. So I'm going to do the 4x here, and that gives me -6x, and -4x is -10x. All right, what is the only difference between 13 and 14?
The 3 is negative.
The 3 is negative.
How did you know that on the last one, the -3 and the -1 had to be negative?
Because you're multiplying to get a positive, but you're adding to get a negative. What do the signs have to be to multiply to get a positive number, but add to get a negative? All right, now this time we're multiplying to get a negative, so we automatically know they're different signs. We don't know which one's which. We don't know if the one's positive or if it's negative. We don't know which one yet. Okay, so this one we have to play with a little more.
Puzzle.
It is a puzzle. Okay, so now we need to get different sign and 10. Do y'all see if I do 4 here, that gives me 12. And if I do 2 here, that gives me 2. Can I make 10 out of 12 and 2?
Yep.
Yeah. How do I get a negative 10? I need a negative 12, don't I?
Negative.
So where does the negative go?
Negative 1.
With the 3.
Oh, never mind.
That makes a negative 12 and a positive 2. Math puzzle day.
We're gonna have more of these
Okay.
puzzle days.
Last one we're going to do today.
The last.
My first term is not prime, nor is my last term prime. So I got to do some thinking at both ends. So my choices for 6 are 1 and 6 and 2 and 3 in some order. My choices for 8 are 1 and 8 and 2 and 4. And here's the big deal right here. I know they're different signs, and I know I need it to add up to 13. So I'm visual, so I have to see things sometimes. So I might just go ahead and say, okay, I'm going to bite the bullet and guess that it's 6 and 1. Can I stick 1 and 8 in there, different signs, or 2 and 4 in there, different signs, and get 13? Oh, no, because if I did 1 and 8, that would be 48 and 1. And if I did 8 and 1, that would be 8 and 6. Can I get 14 out of that in any way? So 6 and 1 won't work for me, will it? So what do I have to try?
2 and 3.
2 and 3.
Oh.
Okay. So now, let's do 1 and 8. That gives me 16 and 3. Can I get 13 out of 16 and 3? Yeah. So let's go with that. 16 and 3. Which one needs to be negative?
One on the right.
The one on the right, because that gives me negative 16 and positive 3. Beautiful. Now, I took a really long time going through how my brain thinks when I do this. But your brains think a lot faster than that. I was just saying it out loud. So what you're going to do tonight is practice factoring using trial and error. You guys have to master this topic. It has to be quick, and it needs, we talked about this yesterday, it has to be quick and just completely right all the time, which we're never completely right all the time. We're always going to mess up occasionally. But we want to be really good at this. Now, some of you know another method to what I taught today. Do not use it tonight. I want you to practice trial and error. And I know sometimes different teachers teach the other method to start with, but you guys are in my accelerated class. You're the kids that are good at math. And the other method takes longer.
Is that where you like?
We don't. It's a.
Because I don't understand like this way. Really.
It's a lot of guessing.
This is what we're doing today.
I'm not good at like guessing. And
It's
I just-
math.
Let's try this. Nope, we're wrong. Let's try.